Okay, so let's define such a family, right? So now what I claim is that we almost have an intuition of what this family could be, right? So and the intuition comes from JL. JL says that, you know, if I map from high dimension to low dimension using random projections, then the distances are going to be preserved, right? So now somehow can we convert that into a finite set of buckets, right? So we need finite set of buckets, right? So JL is going to not give you finite set of buckets, but the intuition that we are deriving from JL is that, you know, this dot products of random vectors is going to preserve distances. And how can we convert that into finite set of buckets? Well, for Euclidean distance, you know, we can, if when I say Euclidean distance, well, that's how I am going to measure nearest neighbor distance later on. So then I can develop a very intuitive and not so hard hash function, family of hash functions. Okay, so this is the family, right? So the family is defined like this: AB for all A in RD and B in I'll come to this, where W is greater than 0. So I'll tell you what this is. So let X be in a d-dimensional vector. Now I am going to define one function in this bag, right? So this is a bag with infinite number of functions. I am going to define one such function. The function is as follows. Every function is parameterized by so let's call this bag parameterized by W. Every function in the bag is parameterized by A and B. The bag itself is parameterized by a value W. This is a number. So if I give us input X, now what am I going to do with this X? How am I going to put this in a bucket? I am going to do A transpose X plus B and then divide by W and take its floor. Yeah, so A is in RD, X of course the input point is in RD, so A transpose X is a number, B is some number between 0 and W, and W is what is also a number. It's called the width parameter. We'll talk about that as we go along. But so basically what is this going to give us is, you know, you can think of it as, you know, mapping high dimension to one dimensional space, right? So you are mapping some d-dimensional vector to onto the real line, and then in the real line we are cutting the real line using W's, right? So this W is my width parameter. So you can roughly think of it as, you know, the boxes are defined using this W, so to say, right? So that tells me the width of the interval where I want these points to fall in, right? So in some sense, so that's one function in this bag. Now I want to randomly pick a function from this bag, right? So for every A and every B, this function is defined, right? So now I need to give a randomized procedure to pick from this bag, so that my probabilistic guarantees that I put down for a RC P1 P2 sensitive function hopefully hold, right? So that's eventually I want that to hold. For that I need to define how am I going to pick a function at random from this bag, and for that, you know, randomness is defined as follows. I am going now this is where JL helps or at least the intuition from JL helps. I am going to pick A as a Gaussian, standard Gaussian in D dimension, right? So this is just a standard multivariate normal variable, random variable. Yeah, so you can think of it as, you know, you have D components, each component is Gaussian with mean 0 variance 1. So that's my A, right? So because because I know that, you know, roughly I know that if I do A transpose a fixed vector x, A transpose fixed vector y, then, you know, there is some distance preservation that JL is going to hint at basically. Now B, I am going to think of B as uniformly distributed in 0 to W, and we will see why this is useful as we try to argue about the sensitivity of this this family. Well, W is some fixed number, it is a bucket vector, there is nothing random about W. So, once I fix W, a family is fixed, because, you know, I have to, I am defining the function using the W. So, the of course, I am defining the family using W, every function in the family uses W, but then what is unique to every function in the family is the A and B, which parameterizes that specific function. Now, if I have to pick a function at random, then I am saying the way I will pick the function at random from this family is, first I will generate a random A in D dimension as a multivariate standard normal vector. I will pick a B which is uniform between 0 and W, and then for any x in D dimension I will do A transpose x plus B, divide by W, and then, you know, take the floor of it, right. So, if that value after dividing by W, let us say was 2.32, then it is going to go to 2, right. So, the smallest integer or the greatest integer which is smaller than the given value, that is your floor function, right. So, 2.15, the largest integer which is less than 2.15 is 2, that will be the floor of 2.15. Okay, so that's the hash family.